This is A2U7L4, Introduction to Logarithms, and we just got through learning about exponential functions. So now we're going to slide right on into logarithms, and I say slide into it because logarithms are actually backwards exponential functions, and their purpose is to help you solve exponential functions. So we're going to learn first of all how to communicate between logarithms and exponentials. We have a formula that lets us translate anything that's in logarithm form to exponential. Now you can also use it backwards and go from exponential to logarithms. Now this is read log base b of a is equal to x, and that converts to a base b to the x power equals a. That common word there, base, well, it's in both of them. So let's just take an example. Now remember, you're not solving a problem here. You are just learning to translate from one to the other. So start with your base. This is 3. In exponential form, it's still going to be the base. Then this almost becomes muscle memory. You slide over here to this number. That's your exponent. And this number is your answer. So isn't 3 to the second power equal to 9? And that's all there is to converting. Let me grab some examples and we'll look at how to convert from log to exponential, and then we'll do some exponential to log. Okay, let's look at these 3, and we want to convert each one of these to exponential form. So start with your base. 6, swing over here to get your exponent to the third power, and there's your answer, 216. That's all we're doing right now is converting from one to the other. So base 7 to the 0 power equals 1. One more conversion, a base 4 to the negative 2 power, see I'm swinging over, equals 1/16. That's all we're doing is translating. Alright, let's go back the other way. Okay, we have equations in exponential form, and we're just going to convert them to logarithm. Start with your base. You're going to have log. All right, what's your base of your log is the same as the base of your exponential. So you've got 14. Now swing over here. 196 equals, and your exponent becomes the answer. All right, one more time. Log base 12 of this number equals 1. Once again, log, what's your base? 2 of this number over here, 1/8, equals -3. So all you need to do is practice this until it just becomes second nature. This is a base, and then it just makes the circle. Now let's talk about the word common log. You're going to hear this a lot. A common log is a log of base 10. There are an infinite number of bases. You can use any number as a base, but the most common one is base 10. That's because that's what our decimal system is based on. And if you see it written log with no base, then it's understood to be base 10. If you hear it referred to as a common log, that's also base 10. Now let's look at how to actually evaluate some logarithms. Okay, I have 4 examples of logarithms here. Now these all have a value, and we want to convert them, or we want to evaluate them. We want to find out what their real value is. We can convert them into exponentials at this point. And what I do is I set this equal to x. It's just easier for me to follow that path if I have a variable over here, because it's actually what you want to know is what is log base 7 of 49. What this is actually asking you is it is telling you 7 raised to some power is equal to 49. If I convert it to exponential, it's going to look like 7. It's going to come over here. This is my base. To the x power equals 49. So what power of 7 would be 49? X is equal to 2. Alright, this says log of 100. If there's nothing down there, what's actually your base? common log. So this is actually asking me log base 10 of 100 is what? Base 10 to the x power equals 100. 10 to the what power is 100? So x is 2. Alright, log base 2 of 64. Once again, I'm going to put equals x over here. Now, 2 to the x power equals 64. 2 to the what power is 64? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times one more time is 64. So x is equal to 6. Alright, now our last one. Here's my base, and I'm going to put equals x. So take your base, this is your power, equals 1 over 81. And let's just reason this one out. We know that 9 squared is 81. We also know that now this is inverted. So what inverts? Well, a negative exponent. So x is a negative 2. So one more formula to talk about here in the introduction. The change of base formula. All right, this is your base of your logarithm. Sometimes you need to change it to another base. One reason is because a lot of calculators, this one included, they only do common logs. You can only evaluate a base 10 log on this calculator and on a lot of others. So you may need to check your calculator before you fly into a test counting on it. So what can you do if you need to evaluate a log and it's not base 10? Well, you can change it. And all you have to do, x in the formula represents the log that you want to change it to. So if log base, you've got log base b of a, you want to change it to log x, you just put log base x of a over log base x of b. Then you can put that in your calculator. So let's look at an example. Okay, if I have log base 16 of 64 and I have this calculator, I need to evaluate it. I can only do that if I have a base 10 log. So I'm going to rewrite this as log, and since it's a common log, you don't have to put the 10, but you can. Your 64 divided by log base, whatever you're changing it to, over 16. Now I can put this in my calculator. 64 log divided by 16 log equals, and I get a 1.5 evaluation. So once again, nothing hard about it, but you need to practice it so that you can remember how to use this. And that is actually all for the introductory section of logarithms, but this is a section you must practice. It's not hard to understand, but you must practice it. So do your worksheet, work a lot of problems, and then we'll be back with the next lesson on logarithms.